Am I streaming? I think so. It's always a question. Yep, okay, I see YouTube just turned green. Hey everybody, Smitty Halibut here. It's been a while. It's been a few months. I apologize for that. Lots of things happened. Some health issues, kind of energy level, and some other things were going on. I got those taken care of. Don't worry, nothing real bad or threatening or anything like that. Just I didn't have the energy or the time to really kind of spend into streaming. And I also, at the same time, I had some issues with my laptop, my new computer. I bought a new computer. My old computer was about 7 years old, and it was doing fine, but it was time for an upgrade. It was time for something new. And so I bought myself a Dell XPS 15, which is a shiny new spiffy laptop, and it's actually a really nice laptop, except that I bought it right after they came out, and there were all kinds of firmware issues that I needed to get fixed. Dell was pretty good about providing updates for the firmware issues, but they require Windows to install, and I don't have a Windows machine, or I don't have a Windows OS on this machine. I run Ubuntu. So I had to play a bunch of games with trying to get Windows on there without getting rid of my... Anyway, long story short, I ended up blowing everything away, installing Windows on it, getting everything updated, then... I think I installed Windows on half of it, so I think my machine is still set up for a dual boot right now. And then I went and completely reinstalled Ubuntu from the ground up, which means that I had to kind of start over on my podcasting setup here, the streaming setup. So I've got everything up and running now, though. It's not as ideal. The USB in my Thunderbolt dock is still kind of wonky, so I have to plug USB devices directly into the laptop itself, which is... less than ideal. I bought the Thunderbolt dock because it had a single cable that would connect the laptop to all the things. But I do have working USB now. I have my two primary monitors, and I've got one monitor off to the side where I'm doing my OBS monitoring, and it's also the monitor that gets split to various different places in my office that I can use for looking at documentation while I'm at my workbench and that kind of stuff. Speaking of workbench, Prime Day... Amazon Prime Day was during my little hiatus here, my unintentional, unplanned hiatus, and I was able to pick up a new webcam, a Logitech C920. This is the newer version of the one that I had been using, which was a 910, and it's not so much that it's a newer version that I'm excited about, but the fact that I have a second one, which means that I can put it over on the workbench and actually hopefully stream some work at the bench instead of just at the computer. Because I don't know if you've noticed, most of my streams so far have been work at the computer, order boards, and then I come back and say, here's the thing that I finished assembling, and I never actually showed you the assembly. So hopefully we'll be able to set up a camera rig over at the workbench so that we can be doing that as well. What have I been doing while I was gone? Well, because of the same energy problems and health problems and computer problems, I have not been doing an awful lot of electronics, which is good. That means you guys haven't missed a bunch. But there has been one thing that I am particularly pleased with that I want to show you now, and that is this. So, RonQuan is somebody I met at Maker Faire at the Osh Park after party for Maker Faire. A very nice gentleman, and he, I don't know if you can see the URL there. I'll paste the URL for my Osh Park boards below in the comments. Excuse me. And but he designed this headphone amplifier, or he did the circuit for this headphone amplifier. And it is a tube headphone amp, all tube, no transistors at all in the audio path, but it still runs at only 12 volts. So most headphone amplifiers, when you see a tube, amp that only runs on 12 volts, what it's doing is it uses the tube at a much lower voltage than it's intended, typically like a 12AU7, which is meant for like 200 or 300 volts, but it's only using it at 12 volts. And you can still get some useful gain out of it, just not any power. And so you get the gain, you get the tube sound, and then you follow that with a FET. And the FET and a current source actually provide all of the power into the headphones, but they don't really color the sound. So the predominant flavor, for lack of a better word, on the sound you get is from the tube. but all the power is being delivered by the FET. This is a unique design in that it does not have that FET follower. It doesn't need one. So it's using a special kind of tube called a space charge tube. They were designed in the 50s, I believe, kind of when radios and automobiles were getting popular, but before the transistor was a thing, or before the transistor was cheap anyway. In the old days, when you had a radio in the car, because the car only produces 12 volts, and that's not enough for most tubes, so what they had is a physical vibrator, a reed that would go back and forth and turn the 12 volts on and off really quickly, and then it would feed that into a transformer, which would give you the high voltage that you needed to run your tubes. And it was literally a mechanical oscillator that would generate this alternating current through a transformer to give you your high voltage. They failed. They were noisy. It was annoying as all heck. And so the tube industry came up with this space charge tube technology where you can get usable power, not a lot, but you can get usable power out of a tube at 12 volts. You don't need to go up to 200 or 300 volts. And so it could run directly off the power in the car. And it was a thing for about 10 years. Mostly in the 50s. And then transistors became cheap enough. Once transistors became cheap enough, all of these things went by the wayside. So the common one, or the one that Ron was using for the design, is the 12DS7. And it is a pentode? Tetrode? I can't remember whether it's a pentode or a tetrode. But it is a tube, space charge tube. You give it a 12-volt plate voltage. And they use a lot of power on the filament because the cathode needs to get really hot to release a lot of electrons. And then there is the grid that is really, really, really close to the cathode that is sucking all of those electrons off and giving them momentum to shoot them toward the plate. It's the only way you can get usable power out of them. Anyway, so he designed this headphone amplifier around the space charge tubes. And I was super impressed with the thing. It was a noisy environment. We didn't have power, so I wasn't actually able to listen to it at the event. But I was so intrigued that I asked him if he would be willing to share the circuit. And he did. And he posted it online in a web article, a link. Again, I'll post it in the comments below. And so I took that circuit and I added a little bit of... I enhanced it in a few minor ways. The audio path is basically his design. I did a little bit more cleanup on the power, on the DC power, so you'll note that there are 2 resistors here between the power, there we go, power, and the filter caps instead of just the one, which means that I've got a separate filter for each of the sides, the left and right. And then I also added my pop stopper, so you can see the relay down here at the bottom, and then all of the surface mount components on the bottom that are the TL7700 reset controller that waits for the voltage lines to come up to full voltage and stable full voltage, and then they connect the headphones to the output so that it gets rid of all of the pop of the startup transients, especially on tubes because they take a while. So I added those, and then I laid it out on a board. His was all dead bug, meaning there was just a solid sheet of copper that he just soldered components to and used the components to connect other components to components, and there was no laid out circuit board. And dead bug is an interesting technique, but it's not anything I've ever gotten into. So I laid out the circuit board and put it together, and lo and behold, it works really well. It requires high impedance, high efficiency headphones. So you're not going to be driving any planar magnetics with this thing. This is, it doesn't provide a lot of power, but I am currently borrowing my friend's HE600s, or I'm sorry, HD600s. So these are Sennheiser high impedance. They're about 300 ohms, and they are incredibly efficient headphones, and they sound glorious on this amplifier. So that is primarily the thing that I did while all of this was happening. I did that. I got the idea for that, or excuse me, I got the idea from it for it from Maker Faire. I was on a business trip in Seattle with my work laptop when he posted the article, and I'm like, okay, I'm going back to my hotel room, and drew it up and ordered the boards, and yeah. So anyway, I've been working on a BitX40. So I have two BitX40s. I've got one that I'm keeping all analog. I've got the analog VFO on it, and it's in a case, and it's pretty much done at this point. And it works really nice. It is a dream to operate. I really like these BitX40s. And then I have a second one, which has the Arduino in it. And the stock Arduino software kind of leaves a lot to be desired. But there's a guy, A. Munters is his login. What's his name? Allard Munters, PE1NWL, who has been making some wonderful software for it. He's been enhancing a lot of the software, and some of the added features require a few modifications to the BitX to be able to do. Like he can do upper sideband and lower sideband. It will do CW. It has a lot of calibration features for various things. Anyway, I'll provide a link to this as well. I should probably be taking notes on what the links are that I am providing. Links to RonQuan and BitX 40 code. Okay. And so I've been spending a lot of time over at my workbench putting those in place. I haven't actually designed any circuit boards or anything new, really. I'm just kind of implementing somebody else's stuff. So that's working out well. That's pretty much it. I had a secret project that I was doing for work. I mean, it's not secret. It's for work, and I don't really talk about that here. It was another Learn to Solder kit, ESP8266 based, but it's nothing big or special. So, today, let's get to it, because I've already wasted 11 minutes, 12 minutes. By the way, it is bloody hot here today, or at least by California standards. Hot and humid. I expected to get to 80 or 85 inside the house, and so if you see me sweating, I apologize. That's why. Also, if you hear fan noise in the background, I've got a oscillating fan going over there to try and keep me from burning up. Similarly, the only light I have in the room is the white screens shining on my face. I don't have any of my room lighting turned on right now, just to kind of try and keep the temperature down. So let's get to it today. What are we doing? We are working on the wall clock. So let's go back to the desktop. Yeah, I'm trying out it again. We've got live chat up here in the corner. I don't know how easy it is to read on the stream, because I'm not looking at the stream in full resolution. So we've got a few people watching us. Say hi in chat. Y'all will make it onto the stream. I would love to see how well this works. So please provide some feedback on the live chat. And then, of course, there's me down there. I can't put my cursor over it because OBS. And then this is what we're going to be working on today. So the wall clock. Not wall clock. My WS2812 clock. Okay, here we are. Let's go back to... I don't have my hotkeys set up yet. So I made a clock out of WS2812s. You'll see that these are, 7-segment displays, 2 2812s per display, or per segment. And then it's kind of a sandwich of boards. So on this one is just the LEDs, and that part worked out fine. I don't need to redo that part of the board. But this board here had some mistakes. So the idea was that it is a WS2812 that will contact NTP to get the time. So it is an accurate clock. It always knows what time it is. I have a power switcher module here, a buck module. So you give it like 12 volt 1 amp or 12 volt 2 amps or whatever, enough power, and then it down converts that to 5 volts at I think 3 amps. This one is good for 3 amps, and I want it to be able to supply power to each of these USB ports on the side here, because I got 3 devices that I want to charge every night while I'm in bed: my phone, my watch, because I'm an Apple Watch user, and my AirPods, because I am also an AirPod user. So I want to be able to have 3 charging ports on my bedside, and right now I've only got the 2. So I wanted to kind of integrate that into the clock. They're digitally, like the serial lines, the data lines aren't doing anything on those ports, just power. What was the other thing I wanted to do? Oh yeah, so it's also got the little 6-pin down here for the serial modules for programming the ESP8266. Having said that, there is a reset button and a program button. I have since figured out how to rig up a tiny little circuit that will take the DTR signal from the serial port and control all of the DTR, or the program and the reset buttons on the micro directly. So we don't have to deal with the buttons for programming the ESP. I'll make all of that kind of transparent. So that's what I want to do, is I want to replace this board, just the control board, just the top board here, this one, not the display board. The display board is doing fine. I want to control that. I want to update that one. I want to, let's see here, I want to do the programming modification so that the serial module can control the programming, and I want to put a 3.3 volt linear regulator on the output of the 5 volts. So the 5 volts can go to the USB, and then regulate it down to 3.3 volts for the ESP8266, which is not a 5 volt device. The problem being that I have the power to this on the same rail as the power to the USB. So if I do 5 volts on the USB, I have to send 5 volts to the ESP, and that they tend not to like that. They're 3.3 volt devices. So I need to put a regulator on for that. That is what I'm doing. And then the power input for it, for all of that module, is a, come on, there we go. There's a little 2.1 millimeter barrel plug in there in the center, which is not really exposed. Maybe I want to change that as well. I don't know. Anyway, that's what I'm working on today. So let's go back to the desktop view. What I did is I didn't want to get rid of the old version. I don't know why. I probably should. Oh, that's why, because I wanted to keep the display part. What I really need to do is I need to split it into a clock and the controller and the display. But what I've done so far is I have copied the project. So I'm working on a second version of the project, and I'm just going to completely remove the display entirely. Oh, looks like I already removed that page. Yes. Okay. So there was another page that had the clock section on it. This is all of the controller stuff here. So let's go look at what we have. That's just the DC input, the 12 volt input, which, connector 104. Do I have a second connector? I think I provided another input. What? Oh, that's the that's my switcher module. Okay, well, switcher module. Okay, yeah, that's the regulator, the switcher module. So just the 12 volts comes straight in and goes directly to the switcher module, so that everything runs off of the 5 volts. And then now we've got a 5 volt rail, and we've got 3 USB connectors that are all the same. They've got some decoupling on the power, just so that any noise from anything doesn't come in and, I don't know, decouple all the things. Then we have the ESP8266, which this is the part I need to fix. I need to stick a regulator in here. Here's some more decoupling. I think that's meant to be decoupling of the ESP. And then I got a couple of buttons, the program button and the reset button. And we will be adding a little bit of circuit from the serial module, the DTR pin, to both of those as well. And then we got a crap ton of decoupling over here. Most of that is meant for the display. I got to figure out whether all of that is meant for the display. And so I will have to, I think it is, oh. I also have a resistor that I bodged onto the bottom of this board. Let me take the controller board off. Apparently I had to bodge something. What did I bodge? So we got several folks watching right now. Come say hi. Say hi in the chat. Who's watching? I like to know. Okay. So that is, here, give you a bigger screen. That is the bottom of the board, and you'll note that we have, other side. So the decoupling on the USB ports, and then the decoupling on the ESP8266. And then we also have that resistor there. I think that resistor is a pull-up on reset, so I think that has already been added. Right here. Yeah, that's a 10K. Yeah, I think that's just the reset pull up. I think I had to bodge that on there because I forgot to put it into the circuit last time. Yeah, I don't see any other resistors on the board. Yeah, there's nothing else. So, okay. But yeah, otherwise, that's the module that we are going to be redesigning. And yeah, and by redesigning, I mean just making a few modifications. All right, so let's get started. First things first, let's drop a regulator. 1117. 3.3. What is the side? 1, 2, alias. My cat. So we also have got new kittens during this time, and they are currently climbing the carpet that I used to line the walls of my recording booth. Kittens will be the death of us. All right, so I think this is the AP1117 is, I am pretty sure, the surface mount version of this beast. So we are going to, well, go ahead and put that down there. Kittens. Copy that over to there. Actually, you know what? Do I want to decouple on the input and the output? I think I do. Copy block. We'll do that. Copy block, because decouple all the things. And we will delete that one. And then, oh, I should have moved that one. Haha. Let's go ahead and delete that block. And then we'll drop a 3.3 volt power. 3 volt. Yoink. Delete that. Move that. Oh, that actually attached. Okay. Okay. It's probably more decoupling than necessary, but we'll do it. I think that's the only thing that runs on 3 volts. The output from here to the WS2812. Oh, shoot. Ruh-roh. I do not have the connector. So there is a small 2x3 surface mount connector down here on the bottom that is used to talk to, where's the display? My office is so clean, I can't imagine why I can't find anything. Oh, for the sake of Pete, I just had it. Seriously? That goes to the male pins on the display board, and it's just power, ground, and signal. I use 2 pins for each of power and ground because, you know, current. It's probably overkill, but 2x headers are easier to solder surface mount than 1x headers. So that's my argument, and I'm sticking to it. So I got to put that connector back on here. Ooh, shoot. You know what? Hang on. No? Okay, we'll just do it. Con 02 by 03. Woot. I just got to remember what pinout I used. This is going to be that kind of thing that I know I'm going to screw up. So what I'm going to do is I'm going to come over here, and I am going to open recent. Nope, open. Can't have more than one going at a time. Fine, save and exit. Yeah, yeah, yeah. Yeah, yeah, yeah. Yeah, yeah, yeah. Yeah, yeah. So I did not put the connector on this page. I must have put it on the other page. There is no connector. So this is the display page. It's just a bunch of 2812s strung together, right? A whole bunch of them. The input here goes to that one, so on and so forth. It's just a big old string, but the connector would be right there, and it's just tied directly to D2. I have no idea how I got the connectors on here. I must not have saved that. Huh. Well, okay. Seriously, how did I do that? Well, the unfortunate thing is that now it means I need to reverse engineer this to figure out which of these was power and which of these was ground. Which I can do. I have an ohm meter. I don't know if you guys can hear it when I do this. Can you hear it when I do it down here? I don't know if you can hear that. That's showing on the VU meter. Okay. So the one on the edge of the board sorry for not showing this on screen. What? Oh. Okay. Okay. So, what I was doing is ohming out the pins on that 2x3 connector right there, and the pins on kind of these 4 pads here, which are the 4 pads underneath the switcher module, the power switching module. So what I've determined is that on this 2x3 connector here, I know that they are done in pairs because I remember doing that. So the two immediately adjacent to each other in the 2 dimension are the same pin. So the ones on the outside are +5, the ones in the middle are the data line for the WS2812s, and the one on the inside is ground. So what I'm going to do is I'm going to remember inside is ground. And then I am going to put those connectors on, or put those signals on this connector, and I just need to make sure that the ground side is on the inside of the board, away from the edge of the board. So pins 1 and 2 are going to need to be near the edge of the board. Okay. What was it? D2, I think, is the one. Copy. We'll do it that way. Edit. And do left facing. Yoink. Move. There we go. Okay. So that's my connector. Value. Display board. Okay. So I got my power done. I got my display board done. Okay. One more thing. Node MCU ESP8266 DTR programmer. I gotta remember which pin it was, or what exactly the circuit is. That is not the one I want. I think that one is the one I want. Because it only uses DTR, and so it involves 2 diodes and a cap. I think that's the one I want. Yeah. Because the DTR pulls... It is directly connected through a diode, excuse me, to the GPIO 0, which is the program button. And then it is connected through a capacitor in series to reset. So when they pull DTR low, it'll pull the capacitor low, but that capacitor will eventually charge up. And as soon as it charges up, it will pass a threshold and release the reset on the controller. So by pulling a single pin down, we are holding the D0 line down to put it into program mode and sending a momentary reset at the same time. So yeah. That's the circuit I wanted. Okay, so 2 diodes and a cap. Really, cat? Come here. Hey, come here. I'm going to show you to everybody. Oh. Everybody, this is Ezra. Say hi, Ezra. Oh, you're much more interested in all the stuff on my workbench. That's Ezra. And he and his little sister Sabine, oh, Snuggles. And his sister Sabine are named after Star Wars characters from the TV show Rebels, if you've seen it. What's all this stuff? What's going on? This little guy is incredibly curious. He also makes a halfway decent shoulder cat. Whoa, nope. You do not get to go on the workbench. All right. Thank you, Kenneth. All right. I'm putting you down, all right? Say hi, Ezra. If you hear random crashes and clangs and whatnot around, it's him. Really, Kenneth? This is not that kind of show. Anyway, at least we got somebody commenting in the chat room. So, this is what we want to do. If I remember correctly, one of these is a diode... There was something to do that, like you put a diode across the capacitor so that you don't get a reverse pulse on the other direction, or maybe one of these. Anyway, Marcel says hi. We're going to Cupertino Aries networking today. I don't know. Can you guys read that on the stream? My OBS preview window is such a low resolution I can't read anything I'm doing, so I'm not really sure. Let's go full screen there. I am now full screen. God, that looks horrible. I hope that's just a streaming resolution thing. Anyway, yeah, it's okay. All right. Kenneth is telling me that my resolution is okay. My local view of it is pretty rubbish. Okay. And get out of that. Okay. Well, hey, Kenneth, and hey, Marcel. Thanks for joining me today. So we're going to implement this on my board. So I'm going to keep it up on my other screen so I can see it, when unfortunately that means that you guys can't. Oh, ho, ho. I need to figure out which pin is DTR. I think it's right next to the 3.3, which we are not doing. Oh, ground, okay. So I have them labeled on the board, and that's what I'm using as my documentation at this point. So it goes 5.5, which we're not using, ground, and then transmit from the serial module, which goes to receive on the ESP8266. Then scratch that, reverse it, and then DTR, and then 3.3. So this is the DTR pin right here. Okay. So let's add a tag. DTR. Boonk, boonk. Okay. Then I want a diode. Seriously? D small. Yeah. Yeah. And then a capacitor. Now I got to do the math. What is the impedance on these? I think they're about 10K. Because you need the reset to be held long enough. I think I'm going to put a 10 microfarad. They're not actually polarized. I don't know why I used a polarized component for that. Is that right? Yeah. Yes. And then I need, okay, move that over there. Copy that one. Yes. Why did I need that? Did I do that the other way? Okay. So I implemented this very same logic on a project I'm doing for work. Yeah, I guess I did add 2 diodes, didn't I? Okay. Okay. I think that's it. I was also talking about putting the resistor pads here across the D- and D+ so that you could signal to the USB device that's plugged into it how much power to draw. But if it's left open, then it will pull the minimum, well, not minimum, but I think it pulls 500 milliamps, which I've only got a 3 amp module. I mean, I suppose I could push it up to 1 amp, but that wouldn't leave any power for these. Yeah, I kind of want to keep it at 500 mils. So if I have no D0 and D and D+, it'll pull the default, which is 500 milliamps, and I think that's what I want. So, yeah. From a circuit perspective, I think that's it, except that I don't want any of this, because all the decoupling on the controller board is handled elsewhere. So I'm just going to delete that block. Famous last words, right? Did I miss anything? Is that it? You know what I do want to do? I want to put another power connector here. Sorry, let's zoom in so you can see. Should probably do some protection here too. If I was smart, I'd stick a fuse in here and maybe a reverse voltage diode. Do I care? I should. Kind of don't. All right, what am I missing, Kenneth? I think that's it. I think that's all the stuff I wanted to do. What did I do? Okay. Schottky. Small. Diodes. SMD. Do I have... Yeah, I do have surface mount Schottkys. Why are there through holes showing up in my... Oh, because I'm not filtering on library. That's why. See, you never get a sense of scale when you're looking at this. How big is that? Is that about the size of a 1206? Yeah, because there is 0.05, so that's 0.1 from there to there. Yeah, I think that's the one that I use. Oh, really? Can we not just keep that on top? Nope, too small. All right, those are the diodes I have. All my capacitors are 1206s, which is true. I've got a power in barrel jack. I've got a power in this. I'm going to be just doing a pin header. Pin headered. Oh, straight or angled? I know the only difference is the artwork. You know what? I don't know. We'll do straight, and I'll just put it at the edge. Well, yeah, whatever. Angled. We'll do angled. I'll put it at the edge of the board. I want it at the edge of the board anyway. Display board. Oh. Pin header. No. This is a surface mount one. What did I do? How did I do this before? Did I make a component? Some B packages? No. Should probably go back and look at my oh. That's not what I wanted. That's what I wanted. I should probably go back and look at my video. Where? What? Socket strip. What is a socket strip? How is that different than the pin header? That, wait, what? I'm so confused. Seriously. Terminal blocks? No. This is thrilling TV, isn't it? Wire connection bridges. Nope. How did I do a surface mount connector? Connect. Seriously. Okay. This is what I'm looking at. Where the hell did my cat just level up to? Oh, they're down there. They're fighting underneath my crap. Beginning to wonder whether I made my own socket or my own board layout for it. Well, there are the USB connectors. Okay. Shut it. Yes, I know. No, I don't want to save you. Okay, barrel jack. I literally did not put that in there. Because I did. Wait, what? This is the uncompleted version. Well, that would explain a lot. Well, shoot. Do I not have the version that I ordered? Yeah, that's a different one. That's where I've got the software. I apparently don't have... Huh. I can't find the files that I ordered. This doesn't exist, apparently. At least not on the files on my computer. Well, crap. Shit. Okay. The reason I'm freaking out about this is because I was hoping to not have to modify most of the layout of that board, specifically where those sockets are, not the sockets, the mount holes and where the connector is, because the mount holes and connector placements are critical because it has to match up with the other board. And I don't know where those files are. I wonder if that was a I wonder if that was a Spider Oak wackiness from having too many machines trying to update the sync file at the same time. Okay, well, let's go figure that out. So, got a few other things we need to do here. Let's go ahead and get the voltage regulators. Dude, seriously? All right. Housings. No, what? SMD packages. There we are. Where? The hell's the SOT stuff? It's not what I had in mind. There we are. Okay. Now I have to remember what package it is that my regulators are in. Stand by. SOT 223. That's the one. And then footprint libraries. Buck boost module. Libraries, buck boost modules. Okay, found it. Okay. Serial, micro, yep. These are all the components that I've laid out over the years. Rotary encoder. Oh, I do have a resistor, don't I? In here somewhere. There we go. I seriously have no idea what I did for that connector. It is not through hole, so it is not a standard pin header. Oh. So it does have a neat feature of show me all the components with this same number of pins. Oh, transformer. Nope. Hello, cats. Oh, oh. No, ceramic filter. Nope, too small. Well, isn't this exciting? Okay. Let's go make a package. Wasn't intending to do this, but all right. What am I doing? Browser, library editor. Nope, not the library editor. I want to go to the component editor, the outline editor, which is not that one. Footprint editor. That's the one. Open a library. New footprint. Con 2x3 SMD. So, nope, they are not surface mount. What are they? No, they are. Oh, crikey. Give me inches. I'm one of those imperial jerks. So 1, but let's edit this. Let's make it a surface mount. Let's make it rectangular. Position. Is that position? Size 0.06. No, I need it to be longer. In the X direction. I want it to start directly underneath, but I want it to extend out by another. We'll do that. But the position is going to have to be 1. All right. I think that's what I want it to do. So that edge is the same, but it extends out 0.1 in that direction. 2 is directly across. Okay. 2, 3, 4, 5, and 6. Okay. So that's 0.1 space. Yep. Those are 0.1 spaced pins. And I think that'll work. Okay. Where's my grid? Make my grid much smaller. Doink. And I'm going to do bunk, bunk, bunk. To show pin 1. Okay. Spent way less time making the component than I did looking for the damn thing. Okay. I'll notice I use a lot of my library components here. That's okay. We'll close that, then we'll save a netlist, generate, save, and then we'll open up that. And we will read a netlist. Unconnected tracks, let's say our footprint selection timestamp, exchange footprint, keep change. I want to change extra footprints, delete, single pad nets, keep, okay. So that's going to delete all the components that we've removed from the schematic, like all of these and a lot of these. And then we'll go from there. Are you sure? Yes, I am. Okay. Okay. Well, this would be a lot easier if I could just reverse engineer the other design files, but I can't find them. So let me go get my calipers. I'll be right back. Blast. Knocked over my headphone hook. There goes my circuit board. I am not having much luck today. Yes, thank you, Kat, for chasing my circuit board for me. Hello, Sabine. What did you do with my circuit board? Got it. Oh, and calipers. So, overall board size is, I'm in millimeters. Whoops. .80 inches long and 1.85 inches wide. So 2.8 long, 1.85 wide. So let's add graphic line. We're going to do edge cuts. So I'm at 1 and 5 right now. So 2.8 long. It's going to take me out to 3.8. And then from 5 down to, what did I say? 1.85. So 5 down to 6.85. Oh, dang it. Down to 6.85. Hey, Joel. How you doing? All right, that's my board outline. Is that about the same shape? Yes, it is. Now I got to figure out where the holes are. .185. What? No. Mount holes. Just chilling. Long weekend. Nice layout on the screen. Thank you. So nice new layout. So you can read the text, okay? Because my preview window over there is much lower resolution than what I'm streaming in, so it's hard for me to tell what's readable or not. You can read it, okay? Mount holes. Yep, cool. 3mm mount holes, which is really kind of annoying because it's actually 3.2, and they don't have ones with the, yeah. KaiCad, will you stop knock it off playing around with your libraries? Okay, so as almost certainly. Oh wait, no. Almost certainly not 125N. That is 0.2 in. Maybe even 0.225. Nope, 225 is too much. Let me do this. .525, and then 2.525 minus 0.125. Oh, math. .525 minus 0.125. 2.4. So 2.4 center to center, which means I believe, what did I say it was before? 2.8. So that is a 3.8 from a 1. So that's 2.8 wide. And if it's 2.4 center to center on these, 2.8, so it's 0.2 in. Nope. We'll do them there. Okay. .685, so 665. And another one here. Okay. Oh. I think those are the bits that need to be locked in place. You can see the chat over the video in landscape. On mobile devices, oh, you're saying that the YouTube app on mobile already shows the chat. I don't need to put it on the screen. Yeah, but when you can't do that, and also that doesn't show up on the replay. So this stream is as much for live streaming as it is for going back and watching after the fact. And so I want to make sure that it is... what I'm really trying to do is I'm trying to capture all of the chat for the replays. Because otherwise, if you look at the video later, then you hear me responding to chat, but you don't actually see what the chat was. So like right now, we've got 4 people watching, but I end up getting 100 views or whatever it is on any given video. Now, I'm not saying that everybody's watching the entire time. I'm not that naive. But yeah, just saying why I'm doing it this way. Why I'm trying to anyway. Okay, then the one other thing that is position critical is that connector. Okay, I gotta figure out where that is now. Looks like 1.225 center line from the edge. That's the one. 1.225 center line from the edge. So the edge is 1.225. And then how far in from the edge is it? I think it's right about there. Oh! Haha, rotate. Ground on the inside, right? That's what I remember. All right, and then the center is 175 in. So 1, 2, 3, 4, 1, 2, 3. Perfect. Okay, so that is where that goes. Assuming my caliper skills are holding up. Now, can I lock all of that? Okay. Is there not a lock? Lock pads. Lock footprint. Okay. Haha. Edit. Lock. Edit. Lock. So now I will not accidentally move these around. Lock footprint. Can I do the same thing with the outline? Doesn't look like it. Edge cuts, can I? Nope, okay. Oh, sounds like my wife and daughter are back. Okay. Hello. So, oh, wait. Edit. Unlock. Edit. Nope. Move. Flip. Rotate. All right. Needs to be on the bottom of the board. because I'm going to have all the components on this side and then the connector on the top there. So if I'm looking at this right, yeah, because it's not centered, so it needs to be on the bottom on that side. Yeah, that's right. And then everything else will go on the top. Okay. How long have we been going? Hour and 15? All right. Which way is which? Out. Move. Rotate. That's how I did it last time. Those are not the right USB connectors. Zip. That's supposed to go on the bottom layer. I will have to replace those USB connectors because those are not the right ones. Hello. Kind of wanted that right there, but it's not going to fit. Rotate it. If I were to make it a vertical, I could probably do vertical like that, huh? Yeah, we'll do that. All right. So, a couple of changes that need to be made. Let's go back here. We'll do that. First off, USB. Connect. Give me my view. USB vertical. Okay. And then power in, pin headers angled. I want to make that straight. Okay. Read netlist. Unconnected. Change footprints. Extra footprints. I didn't delete anything, so that's fine. Okay. So. No red in here. All green and gray. That makes happy. Yay, new connectors. Brand new device. Was it used or new? Dell now sells Ubuntu computers. Brand new device. Was it used or... You're talking about my laptop? Yeah, the laptop is new. It's an XPS 15. Dell's been selling Ubuntu for a while. The XPS 15 did not have a Ubuntu option, and honestly, I'm not afraid of installing Ubuntu myself. All I want is for Dell to support it. And they did not have any of the firmware update utilities for Ubuntu. So, yeah, I'm mildly bummed about that, but it's not the end of the world. It might support it in the future. Yeah, that'll be nice. I'll be honest with you, I'm not going to hold my breath in the meantime, though. Project Sputnik. Do you work for Dell? How do you, I mean, is this insider knowledge or just things that you've read on the net? Because if you've got insider knowledge, let's talk. Just saying. Oh. Well, no, I don't want to do that. Okay. Do I want those sticking out a little bit? I think I want those sticking out a little bit, actually. Bonk, bonk. Bonk, bonk. Bonk, bonk. Ubuntu Podcast. LAS, Linux as a Service? I don't know. Linux Action News and Ask Noah Podcast. Ah, gotcha. Okay. So you are keeping up on Linux news a lot better than I am. Is that on the outside? It is on the outside. Okay. Okay. So this edge here is on the inside of the clock, which is why I don't mind having this kind of overhanging. It's not going to be overhanging outside. These I want to extend a little bit past a possible case I might someday print or mill up or something for this. Yeah. I don't know. It's looking pretty good. Let's put the parts in places. I'm going to need some capacitors on these. I'm going to need some diodes down over here somewhere. Really? Sam's not happy with the new kittens. Not at all. What? Did I do that right? Oh. Hold that thought. Oh, shoot. Did I? Oh, come on. Oh, no. It's a different window. That one. So I think I screwed it up. It points away from GPIO toward the serial module. Yep. I moved that one. Rotate, rotate. There we go. Away from GPIO toward the serial module. Yep, that's what I wanted. Glad I caught that. Netlist, read. Yepers. Okay. How do I back up my data? I back up using Spider Oak, but I don't blame the loss of these files on Spider Oak. I had some weird issues with having multiple laptops under the same mumble something, and it was I had some synchronization issues that were my own fault, I think. Figuring out what data is current when you've got multiple things updating the same data is very difficult to do, and I don't really blame that on Spider Oak. It would be nice if we could just sit here and say, hey, this, the program should be smart enough to do all this stuff for us, but I know enough about how this stuff works to know that that's not really feasible. So, yeah, no, Spider Oak I've been super happy with in general. I use it for synchronization of data between multiple machines. That's one of the reasons why I wanted to replace my old machine, is because I had my big beefy desktop, and then I had my laptops, which were relatively inexpensive hand-me-downs from work, and I had to keep data synchronized between them, and that was always a raging pain in the butt. So getting a powerful laptop, this laptop is more powerful than my previous desktop was. It's not hard. My previous desktop was 7 years old. Actually, I think it was closer to 8. Anyway, it was kind of getting long in the tooth, and so this laptop has all the power of my previous desktop and then some, and it's a single data source. I can just pick this laptop up with me and take it with me, and I don't have to worry about keeping data synchronized. So that's a lesson learned on my part. Hey, look, some 3.3 decoupling. So we'll put the 3.3 decoupling where it's supposed to go. Those are all 5.5s? They are. So it doesn't matter where they go. Just grab a cap and plop it down. Okay. So, oh, nope. Oh, just kidding. That one matters. Okay. And we'll do some decoupling over here. I'm going to need a total of 6. I've already grabbed one, so 1, 2, 3, 4, 5. I was afraid of that. 1, 2, 3, 4, 5. See if we can grab these. There we go. Actually. Oh, why do you Damn it. Okay. Oh, whoops. Haha. Dang it. Flip. Okay, good. Footprint. Okay. So we got our decoupling caps on the bottom. Where did my schematic have those going? Did I actually allocate a location for those decouples? So I got those there. I got the ones on the input and the output of that. It did not allocate any decouples to the serial module. So just those, and those. Fair enough. I think that'll be good. Famous last words. Oh, that's a reset pull-up. That's pulled up to 5. That's not right. There we go. That's better. Save and then make a new net list. Generate net list. Save. Yep. Net list. Read. Yep. And whoa. Close. Okay. There we go. Okay. And then we decouple the inputs. That's my 5. Okay. So I have to decide whether I want, or which side I want ground and which side I want power on. D0 is up there. I think I want ground on the bottom side. Gonna have to via no matter what for the decouples. And I got more grounds over there. Okay. So let's pour a bottom copper for ground. Boink. Bottom, ground, go. Okay. And then we will pour a top copper for +5. I am not going to bother pouring a copper for 3. Okay. And B, what does that look like? What's our bottom look like? That's pretty good. So I gotta remember that I can move some of these to the bottom layer. Like I think I'm going to move all the 3.3 volt stuff to the bottom layer because it doesn't do me any good to have it at the top layer except for these here, but all of this would benefit from being on the bottom layer because it's got the ground pour there. capacitor flip. Move. Nope, just kidding. Flip. Rotate, rotate. This is my other kitten, Sabine. She is also a snuggler. A little camera shy, though. Say hi, Sabine. Yeah? She's a snuggler. Well, she doesn't make as good of a shoulder cap because I need to continue to hold her like this. All right, Sabine. You say hi? Nope. Time to put you down. Okay. Back to work. You know what? Actually, I've been going for an hour and a half. I'm going to take a quick break. We'll come back and do another episode, possibly even this weekend, because it's a 3-day weekend and I don't have anything to do. So I am going to take a break, though. Thank you, Joel and Kenneth, for joining me in the chat room today. Yeah, that's it. I'm kind of curious how and why I lost all of my previous work on this, but wackiness. But this is making good play. There are 2 Joels. Hello, Kitty. Hi, Mark. We have 2 Joels. Well, hello, Joel GJ and Joel Hudson. Thank you very much for both for joining us. See, there's Joel. I hope you didn't just join me and then to hear me say that I'm wrapping up for right now. Joel V2, the other Joel. Anyway, I'm going to take a break. I'm going to go off and go do some other things. It's about lunchtime here in California, and I just kind of want to take a break. I've been doing this for a bit. I'll be back possibly later today, possibly later this weekend. But since I got my rig up and running again, I'm really kind of getting back into the swing of streaming. So hopefully we should be doing this more often. If you have any questions about what it is I'm doing or any recommendations or anything like that, do not hesitate to hit me up on Twitter at Smitty Halibut, or you can post questions down below in the comments in the YouTube video. I read those as well. And we'll catch up with you later. Yeah, thank you so much. Be good humans, and we'll see you later. My little post-show dance, waiting for the stream to catch up. A little dance so that I can look at it down there in my preview of the stream. And we are out. Be good humans.